Good day, everyone. I am Novi Asertimas, and for today, we will be discussing some of the items of the problem set involving linear algebra. So we have here item number 1B. Use Gauss-Jordan elimination in each of the following system of linear equations. For B, we have the system of linear equations 2i sub 1 minus I sub 2 plus 3i sub 3 plus 4i sub 4 is equals to I. For another equation, we have I sub 1 minus 2i sub 3 plus 7i sub 4 is equals to 11. And for another one, we have 3i sub 1 minus 3i sub 2 plus I sub 3 plus 5i sub 4 is equals to 8. And another one is 2i sub 1 plus I sub 2 plus 4i sub 3 plus 4i sub 4 is equals to 10. So we have here follow the solution. So using Gauss-Jordan elimination, we can now create this matrix. So you see or you can we can just write the coefficients of the system of linear equations. So as you can see here, the first row we have 2, -1, 3, 4, and 9. It came from this equation. And then for the next one, we have 1, 0, -2, 7, 11 is for this equation. And we have 3, 3, 1, 5, 8 is for this equation. And another one is 2, 1, 4, 4 for this equation. So as you can see here, for the first column, the row 1 and the row 2, there is 2 and 1, so we can just interchange this row and this row, since we have already established the 1 in the row 2, so we can just interchange this to row 1 so that we don't have to divide it by itself to form a 1. And with that, we have here the second one. So we have here 1, 0, -2, 7, 11, and then 2, -1, 3, 4, 9, and then 3, 3, 1, 5, 8, and then 2, 1, 4, 4, 10, since we have interchanged the row 1 and the row 2. And for us to establish the column 1 in the row 2, 3, and 4 to be 0, we have here the 2, 3, 2. So for the row 2, we have to subtract row 2 minus 2 row 1. So for that, we can establish the 2 to be 0. So 2 minus 2 times 1 is equals to 0. And then -1 minus 2 multiplied to 0 is equals to -1. And then 3 minus 2 times -2 is equals to 7. And then 4 minus 2 multiplied to 7 is equals to -10. And then 9 minus 2 multiplied to 11 is equals to -13. As for the row 3, we will also subtract the R3 and the -3 R1, since we want to establish 3 to be 0 in the column 1, row 3. So 3 minus 3 times 1 is equals to 0, we have here. And then the 3 minus 3 times 0 is equals to -3 here. And then 1 minus 3 times -2, we have 7. And also it follows for the 5 and 8, so we got -16 and -25. As for the row 4, for these two to be 0, we have to subtract row 4 and 2 times row 1. So 2 times 1 is equals to 0, so we have here the 0. And then it follows for this row, so the 1 before the 4 and the 10, so we just have to subtract row 4 and the 2 multiplied to row 1. So we got the answer, which is 1, the 8, the -10, and the -12. So here we now create another one. So for this, we will focus now on the second column, which is here. So for this negative 1 to be positive 1, we want to establish this to be positive 1, so we just have to divide it by itself. So we have row 2 over negative. Divide it by itself for the row, for the column 2, row 2 only. So we have r sub 2 over negative 1. So it follows here for this row. So we get 1 since r sub 2 over negative 1. So negative 1 over negative 1. And for the 7, we have 7 over negative 1. So we got negative 7. And then negative 10 over negative 1, we got 10. And then negative 13 over negative 1 is equals to 13. So since we have here, as you can see, the 0, so we can just copy all those row 1. So we get here 1, 0, negative 2, 7, and 11. And then we will focus now on the row 3, and we want to establish negative 3 to be 0. So for this to be 0, we have r sub 3 plus 3 multiplied to r sub 2 over negative 1. So negative 3 plus the 3 times r sub 2, which is the 1, so we have 0. And then it follows for all the row, for all row 3 here, which is the 7, negative 16, negative 25. And following that operations, we got negative 14, 14, and 14. Okay, so next one is for the row 4. So for this one to be 0 here, we have to add row 4 and row 2. As you can see here, the row 2 in here is negative 1. So 1 plus negative 1 is equals to 0. And then follow the 8, negative 10, and 12, negative 12. So we get 15, negative 20, and negative 25, as it will be added to the row 2 here, which is the 7, the negative 10, the negative 13. So now after that, we can now focus on the column 3 here. So now let's first focus on this negative 14. So how can we establish negative 14 to be 1 in the next matrix? So we get r sub 3 is equals to r sub 3 over negative 14. And then it follows in here up to the next one. So since negative 14 over negative 14 is equals to 1, so we get here the 1. And then 14 over negative 14, we got negative 1. And then 14 over negative 14, also negative 1. And another one we have for the row 4. So we should let the 15 to be 0. So for us to have that, so we get r sub 4 is equals to r sub 4 minus 15 multiplied to r sub 3 over negative 14. So 15 minus 15 times the 1, so we get the 0. And then it will follow in here. So negative 20 minus 15 times negative 1, we got negative 5. And then negative 25 minus 15 times negative 1, we got negative 10. As for the row 2 also, we have r sub 2 plus 7 times r sub 3 over negative 14, since we have negative 7 here and we want to establish here for the next to be 0. So following this, we can create the 0, the 3, the 6. As for the row 1, we have here r sub 1 plus 2 multiplied to r sub 3 over negative 14, since we have the negative 2 here and we want it to be 0. So we have the 0, and then r sub 1 plus 2 times the r sub 3 over negative 14, which is the negative 1, so we have the 5. And then the 11 plus 2 multiplied to negative 1, we get 9. So hence we have this in this form now. So the next one, we will now focus on this. So let's focus first on this the row 4 column 4. So for this negative 5 to be 1, we have here r sub 4 over negative 5. So we get the 1. And then negative 10 over negative 5, we get 2. So another one, for this negative 1 in the row 3 to be 0, we also have here r sub 3 plus r sub 4 over negative 5. So we have negative 1 plus 1, so we have the 0. And then negative 1 plus the 2, we get 1. Another one, for the row 2, we have r sub 2 minus 3 multiplied to r sub 4 over negative 5, since we have 3 here, and then we want it to be 0 for the next one. So we have 3 minus 3 multiplied to 1, we get the 0. And then 6 minus 3 multiplied to the 2, we get the 0 also. And as for the row 1, since we have 5, so we can just to be 0 for the next, we have r sub 1 minus 5 multiplied to r sub 4 over negative 5. So 5 minus 5 multiplied to 1, since this is our r sub 4 over negative 5, so we get the 0 also. And 9 minus 5 times the r sub 4 over negative 5, which is the 2 in this column, so we have the negative 1. So hence, this is our final matrix using the Gauss-Jordan elimination. And then, converting back to a system of linear equations that we have, which is this. So since we have this linear equation, so in this result of this Gauss-Jordan elimination, we can just convert that into linear equation. So we have here since we have here the 1 in the column 1, so this is our I sub 1. And then we have here the result, which is the negative 1. So we have I sub 1 is equals to negative 1. And for the I sub 2 here, we have the 0. So our I sub 2 is equals to 0. And for our I sub 3 here is equals to 1. So we have the I sub 3 here. And for the I sub 4 is equals to 2. So we get this system of linear equations. And then now notice that this has exactly one solution for each. So we have the I sub 1 is equals to negative 1, I sub 2 is equals to 0, I sub 3 is equals to 1, and I sub 4 is equals to 2. So therefore, using the Gauss-Jordan elimination, we have found that the system has exactly one solution, and the solution of the system of linear equations is this, which is the I sub 1 is equals to 1, I sub 2 is equals to 0, I sub 3 is equals to 1, and I sub 4 is equals to 2. So therefore, the system is consistent. Now let's move on in the item number 2. So perform the indicated operation on the following matrices. So consider the following matrices to answer the following problems below. Compute whenever possible. So we have some of the given includes the matrix D and matrix. So the operations that needed to be solved is 3D minus 2E. So our 3 and 2 here is our scalars. So with that, we can have here 3 multiplied to the matrix D, which is this one. So we have this. And for the 2 will be multiplied to E, so we get this form. We will multiply this one first by 3. So by the rule of the scalar multiplication, so we get 3 multiplied to 1, 3 multiplied to negative 1, 3 multiplied to positive 3, and 3 multiplied to 5, 3 multiplied to 0, 3 multiplied to 2, 3 multiplied to 2, 3 multiplied to 1, and 3 multiplied to 4. So we just have to multiply this 3 for all the values here. For all the values in the matrix D. In the matrix D. Another one is the 2 multiplied to E. So since we have the matrix E here and it will be multiplied to 2, so we get 2 multiplied to 6, 2 multiplied to negative 1, 2 multiplied to 4, 2 multiplied to 1, 2 multiplied to 1, 2 multiplied to 1, 2 multiplied to 3, 2 multiplied to 2, 2 multiplied to 3. So basically, we will just have to multiply 2 to these values in this matrix D. So after that, we can get the product of these two. So we get 3 multiplied to 1 is equals to 3. And then 3 multiplied to negative 1, we have negative 3. 3 times 3 is equals to 9. 3 times 5 is equals to 15. 3 times 0 is equals to 0. 3 times 2 is equals to 6. And then 3 times 2 is equals to 6 also. 3 times 1 is equals to 3. And then 12 will be the product of 3 times 4. So now we get the product of 3 and the matrix D. As for this one, so 2 times 6 is equals to 12, and then 2 times negative 1 is equals to negative 2, 2 times 4 is equals to 8, 2 times 1 is equals to 2, 2 times 1 is equals to 2 as follows here. And also we have the 2 times 3 is equals to 6, and then 2 times 2 is equals to 4, 2 times 3 is equals to 6. So now we get this one, which is the product of 3D and the product of 2 and E. So after that, we will now perform the subtraction. So in performing subtraction, we just have to subtract the row 1 column 1 here to the row 1 column 1 also here, and follows for another columns and rows. So we have 3 minus 12, and then it follows on the other one, which is the negative 3 minus the negative 2. So we got here, and then 9 minus 8, 15 minus 2, 0 minus 2, 6 minus 2, 6 minus 6, 3 minus 4, and 12 minus 6. So after that, we'll now perform the subtraction. So we have known that 3 minus 12 is equals to negative 9. And then negative 3 minus negative 2 is equals to negative 1. And 9 minus 8 is equals to 1. And then 15 minus 2, of course, is 13. And then 0 minus 2 is equals to negative 2. And then 6 minus 2 is equals to 4. Also, we have 6 minus 6 is equals to 0. 3 minus 4 is equals to negative 1. And then 12 minus 6 is equals to positive 6. So with that, we have known that this one is after performing all the operations, so the 3D minus 2E, or the 3 multiplied to the matrix D minus 2 multiplied to matrix E, is equals to this matrix, which is for the column 1 we have negative 1, negative 1, and 1. For the column 2 we have 13, negative 2, and 4. And for column 3 we have 0, negative 1, and 6. So this is the answer. Now let's continue for the number 3. So find the inverse of A, or indicate that it does not exist. When the inverse exists, check your answer by showing that A multiplied to the inverse of A is equals to I. So we have here the matrix A. Since this is a 4 by 4 matrix, so our identity here, or the I, is in this form. So as you have seen here, we have the 1, 0, 0, 0 for column 1. We have 0, 1, 0, 0 for column 2, and 0, 0, 1, 0 for column 3, and 0, 0, 0, 1 for column 4. So this is in this form, the diagonal. The 1 is in the diagonal. So this is our I, and this will be used in finding the inverse of A. So we have form here. We have the matrix A here. So just copy the matrix A. And then for the I, we have also here in the right side. So after that, in finding the inverse of A, we should have this form in the left side. And the answer in the or the remaining here in the right side will be our inverse of A. So for us to start, so this, since we have here the 3 of the column 1, I mean the row 1 column 1, so we want to establish here for the next matrix to be 1. So how to make this 3 to be 1. So we have r sub 1 is equals to r sub 1 over 3. It will follow for all the values of row 1 that we have here. So r sub 1 over 3. So 3 minus 3, 3 over 3 is equals to 1, and then also we have here 1, and 0 over 3, of course it is 0, and negative 3 over 3 is equals to negative 1, and then it follows here, so we get the 1/3 0 0 0. And since it has already been established that we have the 0 0 0 0 for the column 1, the row 2 to 4, so we don't have to change anything on that, and we just have to copy that. So now we get this matrix here. And then we will now focus on the column 2. So since we have already established the 1 in the column 2 in the row 2, so we don't have to change on that, and we will also copy for the next one, and also for the row 3 and row 4, since there is already a 0 here. So we just have to change this 1 here in the row 1 to be 0. So for it to be 0, we have r sub 1 or the row 1 minus the row 2. So this is with respect to the row 2, since mamani ato ang kadang ilat na 1. So with that, we have 1 minus 1 is equals to 0, and then negative 2 is the it came from 0 minus 2, so we have the negative 2, and then negative 1 minus 0 is negative 1, and then 1/3 minus 0 is equals to 1/3, and then 0 minus 1 is equals to negative 1, 0 minus 0 is equals to 0, and also 0 here. So with that, we have formed this. And then we will now focus on the column 3. So for our column 3, since we have the negative 1 here, so it should be positive. So in order for this to be positive for the next one, so we have to r sub 3 or the row 3 over the negative 1. So we get the 1, which is negative 1 over negative 1. And for here we have 1 over negative 1, so negative 1 over negative 1, you get 1 also, and then 0 over negative 1 is 0, and it follows here. So now let's focus on the fourth row. So for the fourth row, it has already been established the 0 here, so we don't have to change anything, and we just copy it like this. And for the row 2, since we have the 2 here, so for this to be 0, we have this. So r sub 2 minus 2 times the r sub 3 over negative 1. So 2 times the 1, 2 minus 2 multiplied to 1 is equals to the 0 here above. And also we have the 0 multiplied to 2, 0 minus 2 multiplied to 1, so we have the negative 2. And then we have also here, as it follows on that, following this, so we get 0, 1, 2, and 0. And for the row 1, so since we have the negative 2 here, so r sub 1 plus 2 multiplied to r sub 3 over negative 1, so we get the 0 here. And following that, we will establish in another, in here, the 1, the 1/3, negative 1, negative 2, and 0. Since we have, for the row 1, we have to add r sub 1 plus 2 multiplied to r sub 3 over negative 1. And for the next one, we will now focus on this column, the row 4, the column 4. So we have to make this negative 2 first to be positive 1. So we have r sub 4 over the r sub 2. So with that, we have the 0, 0, 0, negative 1 half. And for this one, so since we have the 1 here, we just have, for the r sub 3, we just have to subtract r sub 3 and r sub 4 over negative 2 for us to establish the 0, the 0, the negative 1, and the 1 half. For the row 2, so since we have the negative 2, so we have to, and our r sub 4 here is negative 2 also, so we have r sub 2 minus r sub 4 for it, for the r sub 2 column 4 to be 0 in here. And following this r sub 2 minus r sub 4, using this one and this one, so we get 0, the 1, the 2, and the negative 1. Also, for the r sub 1 here, so since we have the value of 1, so we just have r sub 1 minus r sub 4 over negative 2. So 1 minus the 1 here is equals to 0, and then 1/3 minus 0 is equals to 1/3. Negative 1 minus 0 is equals to negative 1. Negative 2 minus 0 is negative 2. And then 0 minus 1 half, 0 minus negative 1 half is equals to 1 half. So after that, we have found that the inverse of A, which is on the right side of this matrix, so this will be our inverse of A. So we get the inverse of A is equals to, for the column 1, we have, for the equals to this matrix. So for column 1, we have the 1/3, the 1/3 0, 0, 0, the negative 1, 1, 0, 0, negative 2, 2, negative 1, 0 for the third column, and for the fourth column we have 1 half, negative 1, 1 half, and negative 1 half. And for us to check if this is correct, we need to equate the product of A and the inverse of A to be the identity. So note that our identity is in this form. So for us to be able to check if this is true and our inverse of A is correct, so we have to multiply the A and the inverse of A. So our A here is in this form and our inverse of A is in this form. So after that, in multiplying this, we have to multiply this row 1 multiplied to column 1, and it follows for another column. So we have row 2 multiplied to the column 1 also, and it will follow until we get into column 4. So first, let's have the row 1 multiplied to column 1. So 3 times the 1/3, so we got 3 times 1/3, 3 times 0, 0 times 0, and negative 3 times 0, and it will be added. Okay, so we have this in this form. For the row 2 multiplied to column 1, so we have 0 times 1/3 plus 1 times the 0, and 2 times 0, 0 times 0, so it will also be added. So we get in this form. And then for the row 3 multiplied to column 1, so we have 0 multiplied to 1/3, and then plus 0 times 0 plus negative 1 times 0 plus negative 1 times 0, so we have in this form. Another one for the row 4, we have 0 times 1/3, 0 times 0, 0 times 0, and negative 2 times 0, so we have here. For the next one, so we will now focus for the column 2, so we have the row 1 multiplied to this column. Okay, so 3 times negative 1 plus 3 times 1 plus 0 times 0 plus negative 3 times 0, so we have here. And for the row 2 multiplied to column 2, we have 0 times negative 1, 1 times 1, 2 times 0, and 0 times 0, so we have here. And then for the column 3, we have 0 times negative 1, 0 times 1, negative 1 times 0, negative 1 times 0. As for the row 4, we have 0 times negative 1 plus 0 plus times 1 plus 0 times 0 plus negative 2 times 0. And another one, we have to focus also the row 3, column 3 multiplied to all the rows. So we have 3 times negative 2, 3 times 2, 0 times negative 1, and negative 3 times 0. And it will be all added. And for the row 2 multiplied to column 3, we have 0 times negative 2 plus 1 times 2 plus 2 times negative 1 plus 0 times 0. For the column 3, row 3 multiplied to column 3, we have 0 times negative 2, 0 times 2, negative 1 times negative 1 plus negative 1 times 0. And for the last one, for row 4 multiplied to column 3, we have 0 times negative 2 plus 0 times 2 plus 0 times negative 1 plus negative 2 times 0. And for the last one, we have to multiply row 1 to column 4 and as well as row 2 up to 4 multiplied to column 4. So we have first 3 times 1 half plus 3 times negative 1 plus 0 times 1 half plus negative 3 times negative 1 half. Also, for the row 2, we have 0 times 1 half times 1 plus 1 times negative 1 plus 2 times 1 half plus 0 times negative 1 half. And another one, we have for the row 3, we have 0 times 1 half plus 0 times negative 1 plus negative 1 times 1 half plus negative 1 times negative 1 half. As for the row 4, we have the 0 times 1 half plus 0 times negative 1 plus 0 times 1 half plus negative 2 times negative 1 half. So after that, we'll perform the operation of subtraction and multiplication. So we get for this one 3 times 1 third plus 3 times 0 plus 0 times 0 plus 3 times 0 is equals to 1. And then for this one also, we have 0 times 1 third plus 1 times 0 plus 2 times 0 plus 0 times 0, we have 0. And 0 times 1 third plus 0 times 0 plus negative 1 times 0 plus negative 1 times 0 is equals to 0 also. And for the row 4 multiplied to column 1, we have 0 times 1 third plus 0 times 0 plus 0 times 0 plus 2 times 0. So we get here the 1 0 0 0 for column 1. And let's focus on here for the second column. So we have the 3 times negative 1 plus 3 times 1 plus 0 times 0 plus negative 3 times 0. So we have 0. And for the next one, we have 0 times negative 1 plus 1 times 1 plus 2 times 0 plus 0 times 0. So we get the 1. And another one, we have the 0 times negative 1 plus 0 times 1 plus negative 1 times 0 plus negative 1 times 0. So we have 0. And then for the last one, we have the 0 times negative 1 plus 0 times 1 plus 0 times 0 plus negative 2 times 0. So we have the 0. So now let's focus on the third column. So 3 times negative 2 plus 3 times 2 plus 0 times negative 1 plus negative 3 times 0 is equals to 0. And then 0 times negative 2 plus 1 times 2 plus 2 times negative 1 plus 0 times 0 is equals to 0 also. And then we have 0 times negative 2 plus 0 times 2 plus negative 1 times negative 1 plus negative 1 times 0 is equals to 1. And we have 0 times negative 2 plus 0 times 2 plus 0 times negative 1 plus negative 2 times 0. So we have established the column 3 here. 0, 0, 1, and 0. And for the last column, we have 3 times 1 half plus 3 times negative 1 plus 0 times 1 half plus negative 2 times negative 1 half is equals to 0. And then we have 0 times 1 half plus 1 times negative 1 plus 2 times 1 half plus 0 times negative 1 half is also 0. And then 0 times 1 half plus 0 times negative 1 plus negative 1 times 1 half plus negative 1 times negative 1 half is equals to 0. And for the last one, we have 0 times 1 half plus 0 times negative 1 plus 0 times 1 half plus negative 2 times negative 1 half is equals to 0, is equals to 1. So we have here the column 4 is equals to 0, 0, 0, 1. So therefore, we have established that the inverse of A multiplied to A is equals to this matrix, which is the identity. So therefore, our inverse of A here is correct. Now let's proceed to number 5. Solve the following linear system by Kramer's rule. So for the 5b, so we have this linear system. So 2x sub 1 plus x sub 2 plus x sub 3 is equals to 6. And then 3x sub 1 plus 2x sub 2 minus 2x sub 3 is equals to negative 2. X sub 1 plus x sub 2 plus 2x sub 3 is equals to negative 4. So for the solution, First, find the determinant of the coefficient matrix. So we have here the coefficient matrix. So since we have 2, 3, and 1 here, and for another one, we have the 1, the 2, and the 1. And also for another one, we have the 1, -2, and 2. So this is our coefficient matrix. So to determine the determinant of this coefficient matrix, we have to multiply this, and then the 1, the -2, and then the 1, and then the 1, and then the 1 and 3. So 2 times 2 times 2 plus 1 times -2 times 1 plus 1 times 3 times 1. And it will be subtracted to the product of 1, 2, and 1, and then 1, -2, and 2, and then the 2 and 1 and 3. So we have 1 times 2 times 1 plus 1 minus 2 times 2. 1 times 2 times 1 plus 1 times -2 times 2, and then plus 2 times 3 times 1. So after that, we'll perform this. So 2 times 2 times 2 is equals to 8, and then 1 times -2 times 1 is equals to -2, and then 1 times 3 times 1 is equals to +3, minus this 1. So we get 1 times 2 times 2 is equals to 2, and then 1 times -2 times 2 is equals to -4, and then 2 times 3 times 1 is equals to 6. So 8 minus 2 plus 3 is equals to 9, and then 2 minus 4 plus 6 is equals to 4. So 9 minus 4 is equals to 5. Therefore, our determinant of the coefficient matrix, or the determinant of A, is equals to 5. After that, we will now solve for the x sub 1 up to x sub 3. So for us to solve this, we have here the determinant of A sub 1 over the determinant of A. So since we have already established that our determinant for the coefficient matrix, or the A, is equals to 5, so we just have to solve for the determinant of A sub 1. So in order for us to solve this, so since we have the determinant of A sub 1, so our 6, -2, and -4 in this linear system, it will be substituted in the first column of the coefficient matrix, and then get the determinant. So instead of 2, 3, and 1 for the column 1, we get 6, -2, -4. So finding the determinant, we have the 6 times 2 times 2 plus 1 times -2 times -4, and then 1 plus 1 times -2 times 1, subtracted minus this. So we have the -4 times 2 times 1 plus 1 times -2 times 6 plus 2 times -2 times 1 over all over 5, since this is our determinant of A. So 6 times 2 times 2 is equals to 24, and then 1 times -2 times -4 is equals to 8, and then 1 times -2 times 1 is equals to -2, minus -4 times 2 times 1 is equals to -8, and then 1 times -2 times 6 is equals to -12, and then 2 times -2 times 1 is equals to -4. So we have this form now, all over 5. And then 24 plus 8 minus 2 is equals to 30. And -8 minus 12 minus 4 is equals to -24. And since it is subtraction, so we get 30 plus 24 all over 5. So 30 plus 24 is equals to 54, and then all over 5. So we get this x sub 1. Next, for our x sub 2, we will just follow those. So we get here x sub 2, the determinant of A sub 2 over the determinant of A. So we have the determinant of A, the 5, and notice that the 6, the -2, and -4 is being substituted now in this column, the column 2, instead of the column 1, since we have the A sub 2 here. And then finding the determinant, so following the steps above, in finding the determinant, we get 2 times negative 2 times 2 plus 6 times negative 2 times 1 plus 1 times 3 times negative 4 minus the quantity of here. So negative, 1 times negative 2 times 1 plus negative 4 times negative 2 plus 1 plus 2 times 3 times 6 all over the 5. So 2 times negative 2 times 2 is equal to negative 8, and then 6 times negative 2 times 1 is equal to negative 12, and then 1 times 3 times negative 4 is equal to negative 12. Minus this quantity, so we have negative 1 times negative 2 times 1 is equal to negative 2, and then negative 4 times negative 2 times 2 is equal to positive 16, and then 2 times 3 times 6 is equal to positive 36 all over the 5. And negative 8 minus 12 is equal to negative 32 minus negative 2 plus 16 plus 36, which is equals to 50. So we get negative 32 minus 50 all over 5. So we get negative 82 all over negative 82 over 5. So this is our x sub 2. As for our x sub 3, so we just have to get the determinant of a sub 3 all over the determinant of a. So we have here determinant of a, the 5, and we will now substitute the 6, the negative 2, and negative 4 onto the third column. So we get 2, 3, 1, 1, 2, 1, 6, negative 2, negative 4. So finding the determinant of this, we get the 2 times negative 4 plus 1 times negative 2 times 1 plus 6 times 3 times 1 minus the quantity of 1 times 2 times 6 plus 1 times negative 2 plus 2 plus negative 4 times 3 times 1 all over the 5. And then 2 times negative 4, we get negative 16, and 1 times negative 2 times 1, we get negative 2, and then 6 times 3 times 1 is equals to 18, minus the quantity of 1 times 2 times 6 is equals to 12, times 1 times plus 1 times negative 2 times 2 is equals to negative 4, and then negative 4 times 3 times 1 is equals to negative 12 all over the 5. So negative 16 minus 2 plus 18 is equals to 0. And then 12 minus 4 minus 12 is equals to negative 4. And since 0 minus negative 4 would be equal to 0 plus 4 all over the 5. So therefore, our x sub 3 here is equals to 4/5. So we get this one. So we have x sub 1 is equals to 54 over 5, x sub 2 is equals to negative 82 over 5, and x sub 3 is equals to 4 over 5. So therefore, using the Kramer's rule, the system of linear equation has exactly one solution, and that solution is this. So x sub 1 is equals to 54 over 5, x sub 2 is equals to negative 82 over 5, and x sub 3 is equals to 4 over 5. Now let's proceed to item number 9. Which of the following vectors in R for raised to 4 are linear combination of v sub 1 is equals to 1, 2, 1, 0. V sub 2 is the matrix 4, 1, negative 2, and 3. V sub 3 is equals to the matrix 1, 2, 6, 5. And V sub 4 is equals to the matrix negative 2, 3, negative 1, and 2. So for our A, we have V is equals to the matrix 3, 6, 3, 0. So we have here the solution. So our V sub 1 here is this, our V sub 2 is this, V sub 3, V sub 4, and then the V is equals to the matrix 3, 6, 3, 0. So to determine whether the vector in R raised to 4 is a linear combination of V sub 1, V sub 2, V sub 3, V sub 4, we will need to find if it can be expressed in the form the A sub 1 V sub 1 plus A sub 2 V sub 2 plus A sub 3 V sub 3 plus A sub 4 V sub 4 is equals to V, where A sub 1, A sub 2, A sub 3, A sub 4 are scalars and an element of real numbers. So equating these corresponding components yields to the system of linear equations below, which is this. So we have A sub 1 plus 4A sub 2 plus A sub 3 minus 2A sub 4 is equals to 3. And then 2A sub 1 plus A sub 2 plus 2A sub 3 is equals plus 3A sub 4 is equals to 6. And then A sub 1 minus 2A sub 2 plus 6A sub 3 minus A sub 4 is equals to 3. And then 3A sub 2 plus 5A sub 3 plus 2A sub 4 is equals to 0. So using Gauss-Jordan elimination, so we have formed here. So we have formed here the matrix. So we get for the column 1, 1, 2, 1, 0, 4, 1, negative 2, 3 for the column 2, and for column 3 we have 1, 2, 6, 5. For column 4 we have negative 2, 3, negative 1, 6. I mean 2. And for the and we have here the 3, 6, 3, 0. So since we have established already the 1 here above for the row 1, so we just have to copy this, the row 1, and then we need to establish the 2, the 1, 0 to be 0. So for the r sub 2, we get r sub 2 minus 2 r sub 1, since we want to establish this 2 to be 0 here. So the 2 minus 2 times 1 is equals to 0, and then 1 times 2 multiplied to 4 is equals to negative 7, and then 2 times negative 2 minus 2 times 1 is equals to 0 also, and then 3 times 2 times negative 2 is equals to 7, and 6 times 2 times 3 is equals to 0. Another one in this one, so we have to establish 1 to be 0. So we have r sub 3 minus r sub 1. So following this, we get 0, negative 6, 5, 1, and 0, since we have to subtract r sub 3 and r sub 1. And since we have already established here the 0, so we don't have to change anything, so we just have to copy this and get 0, 3, 5, 2, 0. So now let's focus on this column. So since we have negative 7, so for this negative 7 to be 1, we have to divide r sub 2 by negative 7. So we get negative 7 over negative 7 is equals to 1, and then 0 over negative 7, so we have 0, and then 7 over negative 7, so we have negative 1, and then 0 over negative 7 is equals to 0. And as for this row 1, so since we have the 4, we just have r sub 1 minus 4 times r sub 2 negative 7 for this to be 0 in here. And then following that in this row, so we get 1, 2, and 3, since we have to subtract the r sub 1 and 4 times r sub 2 over negative 7. As for the r sub 3, since we have negative 6 here, so for this negative 6 to be 0, we have r sub 3 plus 6 times r sub 2 over negative 7. And then following this in this row, so we get 5, negative 5, and 0, since r sub 3 is negative 6, the 5, the 1 is 0, and then added by 6 multiplied to r sub 2 over negative 7, which is the 1, the 0, the negative 1, and 0. Another one for the r sub 4, since we have the 3, so in order for this to be 0, we get r sub 4 minus 3 multiplied to r sub 2 over negative 7. So 3 minus 3 times 1 is equals to 0, and then 5 minus 3 times 0 is equals to 5, and then 2 minus 3 times negative 1 is equals to 5, and then 0 minus 3 times 0 is equals to 0. And now let's focus in here. And we want to establish this 5 to be 1. So for us to get that, we have r sub 3 over 5. So following that in this column, in this row, so we get 1, negative 1, and 0. And since we have already established the 0 here, so we don't have to change anything, so we have to copy 0, negative 1, 0, as well as this one. And since we have the 1 in the row 1, column 3, so we have r sub 1 is equals to r sub 1 minus r sub 3 over 5. So we get the 0, and then 2 minus r sub 3 over 5, which is the the negative 1, so we got the 3. And then 3 minus r sub 3 over 5, which is 0, so it's equals to 3. And as for the row 3, since we have the 5 here, I'm sorry, for the row 4, since we have the 5 here, so we just have to subtract r sub 4 and r sub 3. So 5 minus 5 is equals to 0. 5 minus negative 5 is equals to 10. 0 minus 0 is equals to 0. And now let's focus on this column. So we want to establish 10 to be 0. I mean to be 1. So for us to get the 1, so we have r sub 4 or over 10. So 10 over 10 is equals to 1, and then 0 over 10 is equals to 0. And since we have the negative 1 in the row 3, so for this to be 0, we have r sub 3 plus r sub 4 over 10. So negative 1 plus 1 is equals to 0, and then 0 plus 0 is equals to 0 also. As for this row, since we also have negative 1, so we have r sub 2 plus r sub 4 over 10, and also we get the 0 and 0. And for the r sub 1, since we have the 3 here, so for this to be 0, we have r sub 1 minus 3 times the r sub 4 over 10. So 3 minus 3 times 1 is equals to 0, and then 3 minus 3 times 0 is equals to 3. So now we get this form. Okay, so we have established by converting back to a system of linear equations that our a sub 3 is equals to 3, our a sub 2 is equals to 0, our a sub 3 is equals to 0, and our a sub 4 is equals to 0. So using the Gauss-Jordan elimination, we have found that the system has exactly one solution in the form here, which is a sub 1 is equals to 3, a sub 2 is equals to 0, a sub 3 is equals to 0, and a sub 4 is equals to 0. So we have this one, 3 v sub 1 plus 0 v sub 2 plus 0 v sub 3 plus 0 v sub 4 is equals to v. So therefore, the vector v in r raised to 4, which is this one, our vector v, which is in the matrix 3, 6, 3, 0, is a linear combination of v sub 1, v sub 2, and v sub 3, and v sub 4. Since we have got this exactly one solution. So that's all for today, and thank you for listening. I hope you learned something.